Hi everyone, it's Michael Eilbrock from Diesel Laptops, and today I'm going to show everyone how to look at a diesel injector waveform for a solenoid style injector. This is on a Paccar MX-13 engine that's in a 2014 Peterbilt 587, and I'm basically just going to go over the waveform here to explain how everything works. And then after that, I'm going to show you how much resistance it takes in the power and the ground side to get it to code for an injector circuit fault. And not only that, when I'm putting the resistance into the circuits, I'll be able to show to you what the power looks like and what the ground looks like when you're having a problem. Okay, so the first thing I want to explain here is the red trace here. So this is the positive side of that injector, okay? So if you look here, you take your cursor and you measure it, it's firing at about 51 volts, okay? And if you look here at the very beginning of the injector when it turns on, okay, it stays on a little bit longer here, so it'll open the injector, all right? And then after that, then it pulses it real fast from the positive side, and then it basically limits the current. So it kind of looks like, if you think about like a peak and hold injector on an automotive injector, it's kind of like that. It's just, it's a little bit different because on these type of injectors, the way they get the amount of voltage to fire it at 51 volts is due to the fact that there are capacitor banks inside the computer. Okay, so normally, from everything I've seen, and on this one too, you have two capacitor banks that are in charge of firing 3 injectors per bank. Okay, and then what happens is, alternately, the computer, after it gets a charge from the ground side here on this inductive kick, which is going up to around 50 volts, right here, okay, it gets that inductive kick, and that is what is used to help charge the capacitor bank back up. So it's constantly alternating between banks and your injectors in order to have enough voltage to dump it back into the next injector in the firing order, okay? Now, if you look right here, we're going to zoom in, and we're going to do a measurement here, and I'm going to show this to you as well. So key on, engine off, and also while running, you will see a bias voltage going through your injector. So on this one, it's about 7.4 volts. And then when you go on the ground side over here, we got about, yeah, it's about the same, about 7.5. Okay, so when you have it just key on, engine off, okay, you're going to have the same amount of voltage going through both legs, okay? So if you see that, that's a good sign at first, because that tells you that you have continuity through the coil of the injector, so that's a good thing, okay? But if you see like a way lower voltage than the other one, and it's logging a code for open circuit, and you're at the closest test point that you can possibly be at that injector, what that is telling you is you've already got high resistance in the injector, you need to swap out an injector, plain and simple, okay? So now that I've explained that, the other thing here I want to show you here is how these drivers are working. So here's the red, the positive, and here's the negative right here, okay? So you've got a set, you got 3 high side drivers per bank, per capacitor bank. There's 2 capacitor banks, okay? But then on the ground side, each ground has its own individual driver, okay? So if I were to, let me move this down so we can see this a little bit better on the red trace, and I'm going to zoom in on this. And then I'm going to get some cursors here for time. And as you notice, probably about right there, as soon as that driver, the ground driver switch closes, the positive closes, okay, and then it completes the the circuit path here, okay? And it basically what happens there, once it's grounded, all right, the computer senses it, and then it stays low voltage here momentarily on the positive, but then the computer catches up, and then it dumps the capacitor with the 50 volts needed to fire the injector, okay? So that's how these injectors work. And also Cummins works pretty much the same way as well, okay? So this is very good to know, because this can help you determine whether or not if you have a driver that is failing inside your computer, okay? And you can also, you know, when it initially fires, you can time this out too with your cursors and see how long it takes for that capacitor to dump, okay? So by knowing that on known goods, this will help you. So if you have a bad one day, and let's say, for example, that as soon as it closes, it like either takes way too long to fire, or it fires and it's not enough voltage, you know, then that's indicating to you that you've got something going on inside the ECU. Could be the driver, you might have low battery voltage to the computer, but it just gives you a good direction to go, you know, to find, you know, the problem, okay? All right, so now that I went over that, I'm gonna go ahead and zoom back out of here. And the next thing I want to show is the ground side of the injector, okay? So on the ground side here, let's do some cursors here. I'm going to put this down, and as you notice, as soon as you get current flow through the injector, your ground is going to rise a little bit, okay? So if I zoom in on this, it basically rises up, shoot. It hits ground right here, okay? So practically 0 volts, and then the ground is being pulsed right here. Well, I'm sorry, the positive side is being pulsed, forgive me. So the positive side is being pulsed, and then at that same time, you get a voltage drop going through your ground, okay? But it's letting it go, it's putting voltage to it, it rises up a little bit here, and then it goes back down, because then it takes away the voltage from the positive side. So on average here, at first, when it opens, okay, on this ground side, we're seeing about 3.5 volts. So it's a little bit elevated on this one here, but that's pretty much normal operation right there, okay? So now if I lower it down, when it takes it away, it goes back down to, we're about 2.8 volts, all right? And then the current flow going through the injector, we're at about 14.3, 14.4 amps on the injector, okay? So let me zoom out now, okay? And the next thing that I'm going to show is I'm going to go ahead and I'm going to start up the truck, and then I'm going to introduce resistance one at a time in both sides of the circuit, and I want you to listen to the engine and pay attention, and I think you're going to be very surprised by how much resistance it takes to cause an open circuit on this injector. Okay, so I'm going to go ahead and start it, and I'm going to show you what's going on, all right? Okay, so I've got it running now. Now what I'm going to do is I'm going to put resistance into the circuit, and I want you to pay attention, okay? So alright, so now I'm putting resistance into the ground side, and as you notice here, my ground is elevated, okay? So that's indicating to me I've got high resistance on my ground, and then it's affecting the kick as well, the inductive kick on the ground. It's also affecting your current, okay? Notice that the positive is pretty much staying right at about 50 volts, so we know the problem's not on the positive side. All right, so I'm going to keep on putting resistance in here. I want you to pay attention. Okay, so now we're really elevated on ground on the blue channel, and I'm drawing 1.6 amps. Hasn't shut the driver off yet, and it hasn't coded. All right? And now, just going to readjust my trigger here. Okay, so it's still working. It hasn't shut the driver off. Let's see if I can adjust this just a little bit more. There we go. Oop, go up a bit. Okay. I'm going to keep going here a little bit more. Still going. I can't get it to exactly, shut down. It's because of your trigger, but this just proves a point. It's not even logging a code right now. Okay. And now I'm gonna put the resistance back to normal. Okay, and now it's the code's active, so I got to shut it down and reset it. Okay, so now I've got it inactive again, so I've got it back to normal. Now the next thing I'm going to do is I'm going to show a fault on the positive side of the injector, okay? So let me do that. Okay, so now we're back to normal. Now I'm putting resistance in the positive side. Okay, right there. When I put that much resistance in, I can hear a hesitation in the engine and a roughness. And as you can notice here, when the injector's pulling only looks around 6 amps or so, that's when it's affecting the engine, okay? And here's the deal. There's no codes. So if you come up to this truck and it's got this vibration in it and everything running rough, how in the heck are you going to know what it is without a scope? you're not going to know. You're going to hunt and peck and be all over the place. Alright, so now I'm going to keep on putting resistance into the positive. Now watch. So my voltage is going down. And the spike you're seeing, that's from the capacitor bank. But if you look at the overall slope of it down below, the voltage keeps on going down. Okay? So now what I'm going to do is, since we already know the amperage when this thing cuts out, I'm going to put this back to normal now. Okay? Okay. So now it's smoothed back out. And then as you can see at the top, on the red my positive, I've got the initial turn on, the dump from the capacitor bank, then the computer pulses it real quick and works kind of like a peak and hold style injector. Okay? So that's the difference between the two, and that's what you have to look at. Alright? So if I do this again, let's wait till I hear it hesitate. Okay, about right there. Alright? So I'm going to stop the scope and let's measure it. Okay, so let's see what the amperage was when this started to run rough. Okay, so I was off a little bit, so it's probably, well, I adjusted a little bit differently, but I'd probably say around the range of around 6 to 7.7 amps. It's when you're going to start to hear and possibly feel a hesitation if you're in the driver's seat. Okay, so I guess the moral of the lesson here is if you don't have a scope, you're not going to be able to find this problem. You're just going to hunt and peck and replace parts, and you won't know what's going on. So why the manufacturer made the threshold for an open circuit so much is beyond me, but it is what it is. Okay. So that's what I wanted to show today, show how to look at your injector, how to look at your current, and so forth. Also, another thing to keep in mind on these on the ground side of the injectors, on these solenoid style injectors, if you look here, you've got your inductive kick, okay? So normally if you have a good inductive kick on your ground, and it's where it needs to be, and it'll be around 50 volts or so like I showed you, then what that means is the overall internal health of the injector itself is in good shape, because as soon as you open the ground circuit, all right, it creates a back voltage, all right, and that's due to the fact of the magnetic field that's been generated inside that coil, that, you know, the energy in there. Okay, so then the energy from the coil, it reverses polarity. Okay, so instead of staying at ground, it spikes positive. Okay, and that's what's going on inside this injector. All right, so that's another good telltale sign to look for good health of the coil itself. Now, when we're talking about the pintle hump, the closing hump here on the injector, some of them you can see a somewhat defined hump, a little bit. On this one, it's not really very defined at all. You will see a little bit of a hump on there, but I don't really necessarily take or use that information solely to condemn an injector, especially a diesel common rail injector. It's not like a port fuel injector on a gas engine. So what I like to do is to confirm, you know, the opening or the closing of the injector, not only with looking at ground and current. I'll also hook up to a rail pressure sensor signal wire. Okay, make sure your ground on the scope is on the ground of the sensor, so you take out any excess noise in the electrical system so it doesn't interfere with your measurement. And then you look at the rail pressure as you're looking at your injector when it fires, and then you use the sync, you know, in firing order. and then you're able to determine whether or not if an injector is actually opening or closing. Is it dumping too much fuel? Is it not dumping enough? You know, and so forth. So so that's pretty much it for today. I hope everyone enjoyed this video. And like I said, if you have any questions about anything, feel free to ask me. I'm planning to do more, and hopefully once everything is said and done, a lot of these training videos that I'm doing with the scope are going to actually be embedded, you know, with links in the Diesel Scope software. Okay, so I'm really hoping that we can get going on that soon as well. But anyway, I hope everyone has a good afternoon. Take care, and thank you so much for joining me.